Okay, this is a video for record and for analysis and an update. Okay, fine, yeah. Okay, this is an update of my research for discovering a concept for magnet motor. This is only a concept, it's not a magnet motor. This is a research to discovering a way to provoke a circular motion using magnets and steels. And this concept is for using it in a self-running and a magnet motor and another design that has to develop speed and torque. We have only here like 2 units. For a magnet motor, we have to use several units to develop speed and torque. This is only the concept. Okay, today workshop, I installed one additional shield. This prototype has two components, two parts, a rotor and a stator. In the rotor, we have the magnets. These are the magnets, spiral magnets in the rotor that's gonna feel attracted to the vertical shear, and that's gonna provoke an attraction and a movement forward in one direction. In the rotor, we have the external magnets. These are the external magnets. It's gonna provoke a repulsion effect on the spiral magnet, and it's gonna use the shields, vertical shields, at the spiral magnet pass. In this shield, the last magnet in the spiral arrangement is gonna feel the repulsion of the external magnet. That's going to magnetize the shield with the same polarity of the last magnet of the spiral arrangement magnet, and that's gonna provoke a forward motion, and it's gonna prevent a kickback. So the spiral magnets are going to move always in the forward position. To achieve that, and this arrangement of spiral magnet is gonna move to this side, to this direction, and to prevent the kickback, as it moves to the following shield, it's gonna feel a repulsion in the backward. So the spiral magnet always going to feel an attraction in one direction forward and a repulsion in the backside of the spiral magnet to prevent the kickback and to provoke a forward motion. Okay, so we have two components. The spiral magnet feeling attracted to the shield, to this shield, to the vertical shield, and the external magnet that's gonna provoke the repulsion effect in the back of the spiral magnet, and that's gonna provoke to go forward. Okay, we have two components now. Now I need a third component. I have to put in this area that's gonna provoke another repulsion in the external magnet. So the external magnet are gonna repel the spiral magnet, and the third component gonna repel the external magnet. So to provoke a forward motion. Okay, today in this prototype we have two units. One unit, this is one unit, and this is the other unit, the second unit. You have two units, two shields, and two shields, and two external magnets. One and two, with the other one aquí, and two. So we have two units, and this is a prototype, improvised prototype. Okay, today what I did was to prepare the materials for the third component. That's gonna be here, but I'm gonna come later. And today and this weekend I installed another shield, vertical shield. There's one shield. I installed this shield, two, and this is three. You have three shields, three vertical shields, and two spiral magnets. There's three shield, one shield extra of the all shield. Okay, the mechanism of the concept is the mechanism that's gonna make this prototype move in a circular motion. It's gonna be between two shields, this shield and this shield. As the spiral magnet moves, this side of the spiral magnet is gonna feel attracted to this vertical shield. As it goes in the back side, in the other side of the spiral magnet, in the last magnet, in this area, it's gonna feel always a repulsion. So it's gonna be an attraction and a repulsion. And the repulsion is caused by the external magnets and the third component. I cannot achieve a better repulsion here because of the workshop I'm doing. I don't have good materials, I don't have good tools to make it happen. But in the next design I make, I'm gonna try to polarize the wall, all the vertical shield in the backside in this effect. I only have this small effect. If I make this effect more large, going like half of the vertical shield or a little more, but I can provoke a better effect of repulsion. But in this prototype, I have to use only this small area. But even using that small area, I can achieve a good demonstration. Okay, now I'm gonna make a little push extra to make this spiral magnet move around this shield, and it's gonna go to this shield, and it's gonna go to the other shield, three shields. But I'm gonna make a little push to achieve that. But that little push that I'm gonna do with the hand is gonna be achieved when I install the third component. That is gonna go in this area. Okay, I'm gonna make the movement. Okay, there's one shield. I didn't put a shield here. Okay, there's one shield over there, two shields, and three shields. One, two, three shields, and two spiral magnets. But I'm gonna force it a little bit so you can see the movement. It's gonna go like that. Okay. It's gonna start here. It's gonna go like that. It's gonna pass the shield. It's gonna have a little repulsion, and it's gonna go to the following shield, and then I'm gonna have a repulsion, and then it's gonna go to the last shield. Okay. One, two, and three. See? One. Okay. It's kicking back. See? It's kicking back because it's moving forward, but it still has a little pull backwards. That's gonna make it go like it's gonna have a little force, and that force is gonna make it stop right now. It's gonna prevent it from continuing the movement. That's why we have to have a good repulsion effect and a good repulsion effect over here. In a magnet motor, you have to eliminate that kickback because the kickback is going to cause friction and resistance, and that resistance in the long term is going to make it stop. And I don't want that. I want it to continue without resistance and friction. Always in the attraction, being attracted, and at the same time being repulsive in the backside. Okay, I'm gonna push that a little bit. I'm gonna make some turn for record. Okay, okay. And that's the feedback. And that kickback is what preventing from making a forward motion and circular motion. And I had to work with that. Okay, now the first component, I'm building. I'm gonna make a demonstration. What I'm gonna do with the first component, I'm gonna show the materials I'm building. I have cut. Okay, I cut this iron. It's an iron shield that I'm gonna use in the first component. This is gonna shield the one. This is gonna shield the polarity that I don't want to use in the first component. I want to use only one polarity. So I'm gonna try to diminish the force of that of the unwanted polarity, and I'm gonna do it with this. I have cut this. Okay, I have cut these sticks, wooden sticks. I have 6 sticks wood. Okay, I'm gonna show you what I'm gonna do with the first component in the other side. Okay. Okay, here's the design I'm gonna do with the third component. This is a sketch drawing. ¿Cuántos minutos yo llevo? 40 minutes. Okay, this is the third component. This is a simulation of the third component. This is gonna simulate the external magnet. and this is the third component. Okay, this third component has to provoke a repulsion in the external magnet. That is this part. Okay, but I have to find a mechanism here. I have not discovered yet. I have to find a mechanism to make this thing move only in one direction and stop in the opposite direction. Okay, it has to move in this direction, but it cannot move in the other direction. So when I make the test, I gonna see if this gonna work in that way. Okay, the third component is gonna do like this. This is always gonna be in this position, and then when this thing, the external magnet pass by, it's gonna provoke that push at the same time. In that position, this part, the external this third component is gonna lock in this position, and locking in that position and at the same time moving in the opposite direction of the external magnet, I gonna try to provoke a repulsion effect in this magnet. See, when it look like that, it's gonna try to push, and it's gonna help a little bit in the kickback only, I think, because the movement is gonna be the principal movement provoked by this prototype are gonna be the attraction mode. The repulsion is for preventing the kickback, but the main movement is gonna be by achieved by the attraction mode. Okay, it's gonna lock in this position, and like you see, it's gonna cause a repulsion in the external magnet. See, it doesn't want to be kicked back. It's gonna be like hold in a hold. But that I had to is under test. I had to build now. I have to build this third component. I'm gonna build it like this, and supposedly I had to find the mechanism. Before building this, I had to find the mechanism for locking this in to move in one direction and not in the other. Okay, and then when I build that third component, it's gonna be installed in this area. It's gonna be here because the effect of repulsion that I want, it has to be in this point, exactly at this point. So I installed this component in the correct position of the prototype. Okay, you see, it has to be exactly when the external magnet go in the shield, vertical shield. This repulsion effect is gonna have to be done here. This thing moves with the shield. See, the magnets move in one direction. The magnets move in one direction, and the shields is moving in the opposite direction. Okay. 18 minutos. 18 minutes. Okay, I'm gonna make a little more movement for record. Así. the machine needs, this prototype needs a very good repulsion effect. Yeah, cuando pasa aquí, and these are very strong magnets. I'm using neodymium magnets. They are very strong. Okay. See? If I this is the external magnet, this provoke a repulsion effect. If I have installed in this prototype a more larger magnet like going through here to this point, it should, we should look a better effect here. But these are very strong magnets, and I only could construct this prototype to this point with this material that are very poorly, are wood and aluminum, and they are not like synchronized very good. But we can make a demonstration, a good demonstration here. See, this is the vertical shield. This is the vertical shield. This is the spiral magnet. Have one polarity. It's positive pole, north pole. You see, when this spiral magnet passes at this point, the external magnet are a little bit in the back, more in the back from the spiral magnet. And when it passes this point, this external magnet polarize the shield with the same polarity of the spiral magnet. And that's going to prevent the kickback. It's going to move forward. See? So you have to clean. Then the first component is going to be here, in this area. This area, like that, they're supposed to be there. And then when this passes, this is going to turn, move, and in certain position, it's going to be locked in same polarity. And as it moves, this is going to have to be tested in movement. And when it moves, it doesn't find, it gets locked and do like that and open. It's going to open because of the repulsion effect. It's going to open, expansion. Right? It's going to prevent from the kicking back, and it's going to be more in this area. It's going to feel more attracted to move forward. Okay, so the only thing we need here now, I have to figure out how to find the mechanism that's gonna lock this first component in position to always move in this direction, but lock in the other direction. Movement and lock. Movement and lock. That's the mechanism I had to figure out how to do. So I think I'm gonna stop this workshop for this weekend. I'm gonna think about this thing, and in the next workshop I'm gonna build this component and install it. Install it here and make the test. Bueno, ya. Voy a dar aquí.